That's right, friends. It is time to level up on factoring so that you can master your favorite algebra class. No more time to mess around. Let's get started. Oh my goodness, here we are doing our favorite thing in whatever algebra class you're in, which is going to be factoring. Few things I want you to know about factoring. First of all, the a value or the leading coefficient, that cannot be negative. So if we're about to factor something and there is a leading negative sign, we got to factor that out. Step 2 is going to be factoring out a GCF. Sometimes there's a GCF, sometimes there is not a GCF. And the last thing that we are going to do is we are going to factor by grouping. And that's going to be a self-checker in of itself. So of course we're going to have our special factoring things like a difference of two squares or the always exciting perfect square trinomial or even the more exhilarating factoring perfect cubes. But we're going to save that for later. I am just talking about basic trinomials. So the first example, this has two terms. So I'm not really worried about the third step, factoring by grouping. I am worried about having a leading negative coefficient, and I'm also worried about a GCF. This problem does not have a leading negative coefficient, but they certainly have a greatest common factor. Both of these terms right here, I can take out a 5 and an x. So remember, when you factor stuff out, it's really like reversing the distributive property. So if they both have a 5x I can take out, I'm going to write that on the outside, and then I'm just going to do some basic division. What is 5x squared divided by 5x? That's just going to leave a single x. 20x divided by 5x, that's just a positive 4. So that is all I'm going to do to factor out that GCF, which just has two terms. So when we take a look at this term, when we take a look at this expression, this is a trinomial. It has three terms. So remember, the first thing I would do is look to see if there is a negative leading coefficient. There is not. That 5 is positive. Then we would take a look to see if there are any greatest common factors between 5, 12, and 7. There certainly is not, and I can't take an x out of all three of those terms. So good old-fashioned plain trinomial. This is how I factor trinomials. I'm going to draw an x, which is kind of like the Xbox method if you've looked at that method before, but I just use the x for a graphic organizer. Up here, I'm going to put my coefficient for my b term. At the bottom of the x, it's going to be a times c. And then these two sideways terms, that's actually what I am going to rewrite this middle term with to begin the grouping process. Let me show you what I mean. So my b term is a positive 12. And then 5 times 7, I'm going to multiply those together and put it down here. And then we have to think of numbers that multiply down to make a 35 and also combine up to make a 12. And of course, that's going to be a positive 5 and a positive 7. So I write it like that on purpose with the sign, and I'll show you why. So now I'm going to go back to this guy. I'm going to rewrite this guy, but I'm dropping the 12, and I'm going to rewrite it as the addition of a 5x and a 7x. So it is keeping the a term exactly as is. I'm not writing that. I'm writing my two sideways numbers, plus 5x, plus 7x, and then I recopy the last term exactly how it is, so plus 7. I left the first number alone. I left the last number alone. I didn't write that 12. I wrote these sideways numbers, which is the same thing as 12x anyway, because that's what the answer is when you add those two. All right, to do factor by grouping, I'm going to group the first two terms together, and I'm going to group the last two terms together. And if you notice, I included that plus sign in my second group, so I'm also including the signs. Then from here, it's just all about the GCF. So what do these two have in common? They both have a 5 and they both have an x. So if I take a 5x out of both of those, that's going to leave me with x plus 1. Let's take a look at the second group. What's the GCF for this group right here? Just a 7. So it is a positive 7, so I'm going to write plus 7, and then that's going to leave just x plus 1. Here is the beautiful thing about factoring by grouping. You know you are on the right track if what is left in parentheses matches. That certainly matches. That is going to be one part of my factors. the other part of my factors, the other factor is going to be 5x plus 7. So here's how we write this. Factor number 1, 5x plus 7. Factor number 2, just one of those, even though they match and you see two of them, it's just one. This is factored form of this guy right here. And remember, if I went back and multiplied that and did foiling, first, outer, inner, last, combine the terms, I would end up with what I started with. All right, let's take a look at this example. We've got a trinomial here, and the leading coefficient's negative. So before you even try to factor by grouping or anything like that, you got to factor out the negative. So I'm going to factor out a negative, and remember, when you factor out a negative, it's just like multiplying by a negative. All the signs change. So that was a negative 6a squared. It's going to be a positive 6a squared here. That was a negative 25a plus 25a minus 25 plus 25. So that negative 1, he's just going to hang out there for a minute. I do need to bring that negative back into the final part of my factored form because it is a factor. But right now I'm just focused on what's right here inside parentheses. When I'm looking at this problem and I'm reading it, I notice there is not a GCF. So I'm going to go straight to factor by grouping. So this top box is going to be a 25. The bottom box is going to be 6 times 25, which is 150. So what are some numbers that add up to 15 but multiply down to 150? That's going to be a 10 and a 15. And they're both positive. So here we go. I'm going to recopy that number 1 right now. He's just hanging out for the ride. Or negative 1. Recopy the first term. Recopy the last term. And then instead of writing 25a, I'm going to write plus 10a. Plus 15a. And now we're going to factor by grouping. So I'm going to group the first two together. I'm going to group the last two together, include that sign. And now it just becomes a GCF problem. So for this set right here, 6a squared plus 10a, the only thing I can take out is a 2a. So I'm going to leave this negative 1 alone for a while. I'm just going to focus on my work inside the parentheses. So remember, we can factor out a 2a, so that's going to leave 3a plus 5. Now I'm going to look at the second group, and the only thing I can take out of that is going to be a 5, which is a positive 5, so I'm going to write plus 5. So plus 5, and then this is going to factor to 3a plus 5. So far, so good. I'm totally feeling confident about my work because those two match. So my final factors are going to be 2a plus 5. And then remember, you only write the matching pair once. But do not forget, we factored out a negative 1 in the beginning at the top of the work. So we got to grab that negative 1 and bring it back down to our final answer. And that is factored form of that trinomial. Okay, let's take a look at this problem right here. So remember, you have to see if there's a negative leading coefficient. Nope, 3 is positive. But they all have a greatest common factor of 3, so we're going to factor that out. So that becomes x squared minus 2x plus 1. So this 3, he's just going to hang out for a little bit. We're going to go ahead and drop him right back down in our final factored form. I'm just going to focus what's inside parentheses. So remember, your b value goes on top. A times c is going to go on the bottom. So what are numbers that multiply down to make a positive 1, but when you add them, it makes a negative 2? It's going to be negative 1 and negative 1. Negative 1 times negative 1 makes a positive 1, and then of course a negative 1 plus a negative 1 is a negative 2. So x squared minus 1x minus 1x plus 1. Draw a group, GCF. The only thing that I can really take out of these is just an x. So that's going to turn into x minus 1. Over here, if you notice, you have a leading negative in the beginning. So you need to factor out a negative number and then whatever else they both have. A negative 1x and a positive 1, the only thing that you can take out of that is a negative 1. When I factor a negative 1 out of this group right here, what remains is a positive x minus 1. So we are going to get x minus 1 for one factor, and then our matching factors is also an x minus 1, which means, ladies and gentlemen, that this is the infamous perfect square trinomial. So these are our factors, but that looks silly. That's little baby form. So what we are going to do is turn off my phone, and we are going to write this using the exponent. This factor is also a perfect square. So we're going to write it as a perfect square. But do not forget, we got to go grab that 3 for our final factored form to complete the answer. So this is factored form of that. So here's our next special guest of factoring, and that is going to be our dose. And I did say dose. And dose stands for difference of squares. So let me go ahead and show you how I am going to factor that. Same rules apply. Do you have a negative leading coefficient? Nope. Do you have a GCF? You sure do. So 4 and 100, they both have a common factor of 4. So I need to factor a 4 out. So this is going to turn into x squared minus 25. So I can go ahead and show you using the x as my organizer. I'm going to ignore this 4 right now. I'm going to focus on what's on the inside. If you notice the inside, the b value is missing. You know, the number that just has an x, a single x, a linear term. So the b value is 0. I don't have one. If I did a times c, that would be just a 25. I'm sorry, a times c, a, which is 1, times a negative 25 is a negative 25. So here, I am looking for values that combine to make nothing, in other words, a 0 pair, and also multiply to make a negative 25. And that is going to be a positive 5 and a negative 5. So, looking at just what's in parentheses, x squared plus 5x minus 5x minus a 25. Factoring by grouping. These two just share an x, so that's going to be x plus 5. These two share a negative 5, so I'm going to factor that out. That turns into x plus 5. And now we see that our factors are going to be x plus 5 and x minus 5. However, do not forget that we factored out that 4, so it has to go down here at the end also. By maybe the second week or hopefully the first week, full week of your class, I really like for you to drop this method. I would like for you to recognize that the square root of the first term is just an x. The square root of the last term is a positive 5. And remember, it's a difference of squares. Difference is a minus sign, so they are going to have alternating signs. And of course, that's going to make sense because we don't have a b value. So these have to make a 0 pair in order for the b value to go away for it to be a difference of 2 squares.